Hey guys, so today we're going to go ahead and continue on our lesson of 5.4. So yesterday you guys went ahead and took a look at what solutions are when we're talking about a higher degree polynomial. We learned to identify those through the use of a graph. So wherever the graph hits the x-axis, we can spot where our solutions are or where our zeros are, as well as through synthetic division. And then we actually went a little bit further and we actually applied the quadratic formula to find the missing zeros from the remaining quadratic function after we had divided that out. But let's go ahead and recap that essentially today. So what I would like to do is go ahead and do a few problems of each. And even if for some reason you still didn't get it yesterday for the 5.4 day one lesson, hopefully today after our lesson you guys will have a little bit better understanding of that. So let's go ahead and start off with our first question here. It says, which of the following is not a real zero of the function in the graph? Well, let's go ahead and find the zeros first. Well, the zeros are right here, here, and here. So we have our zeros directly on the x-axis, and that looks like it's at x equals 1. Okay, but remember, guys, we're looking for which ones are not a real zero. So x equals 1 is a real zero. That's not the one that I want. X equals 4 is a real zero. That one's directly on the x-axis. Same thing here. So all of those work except for 6. 6 would be right here. That is not on the graph. So actually, the answer here is D. D is the only one that is not a solution for this graph. It is not a zero for this graph. Okay. The next one says which of the following is a real zero. So this time we want the ones that are real zeros of the function of the graph and select all that applies. So let's go ahead and do the same. So I'm going to go ahead and just use my little dots here. It looks like I have 5 real zeros there. And what I'm going to go ahead and do here is just check which ones are those. Sorry, which one of these 5 choices actually qualify as one of those real zeros. So x equals -3, that is not a real zero, so that's not one that I want. X equals -1 is, so B is an answer. X equals 0 is, that's one of the x-intercepts. X equals 1 is, and then x equals 3 is not. X equals -3 and x equals +3 were not on my blue graph. So no, those were not solutions. So only B, C, and D. All right. By the way, guys, you'll hear me use zeros and solutions interchangeably. For the most part, they do mean the same thing. All right, so you'll hear me refer to them as either zeros or solutions. But for now, since I want to get you guys accustomed to the word zeros, I'm going to refer to them as zeros for the remaining part of this video. So we're going to get a little practice with our synthetic division. This is actually what we did in section 5.3 as well as a little bit yesterday in 5.4. So what we do here is we're dividing both of these functions, f of x divided by g of x. And to do that, we have to go ahead and take a look at our g of x here. And as we did last time, we have to set that equal to 0 to find out what our box number is. All right, so I'm going to go ahead and add 1. We get x equals 1. So our box number here is 1. Now I have to go ahead and put down all my coefficients. This one, this one, this one, and this one. And all my coefficients are going to go here right next to our little box. Okay. So what I'm going to do is drop the first number and then box up the last number. Hopefully we get lucky and we don't have any remainders, but it does happen every once in a while. So here we go. Let's go ahead and do our synthetic division. So we're going to go ahead and do 1 times 1 to give me 1. Okay. Actually, let me make that real quick. So 1 times 1 gives me 1. And then I'm going to drop a 4 down because -5 plus 1 is 4, and actually -4. Let me correct myself. Next, we're going to do 1 times -4. That's going to give me a -4. Again, add the columns. -1 plus -4 is going to give me a -5. And finally, one more time, 1 times -5 is going to give me positive. Oh, sorry, a -5. And actually, we did get kind of lucky here. There is no remainder because 5 plus -5 is just going to be 0. So we can work with this information here, and those three are my coefficients for my new function. 1x squared minus 4x minus 5. And like I said, what we're going to do today is keep working with that because right here, that is a quadratic. We know how to actually solve for quadratics. We know how to find all the zeros or all the solutions for quadratics, but that'll come a little bit later. For now, all we are doing is synthetic division to divide out those two functions. Let's go ahead and try one more. So same thing. Let's go ahead and set our x minus 2 equal to 0. So this is x equals 2. That is our box number. I'm going to go ahead and rewrite all my coefficients here. So 2, negative 7, 7, and negative 2. I'm going to go ahead and bring down the first number, box up whatever last remainder I get. So then this is going to be 2 times 2 is 4. Negative 7 plus 4 is negative 3. 2 times negative 3 is negative 6. 7 plus negative 6 is 1. And 2 times 1 is going to give me 2. And once again, I did get lucky here, guys. No remainder left over. So I got a little smiley face going there. So as I said, guys, this is going to become your coefficients for the new function, which are going to be 2x squared minus 3x plus 1. And once again, guys, that is a quadratic that if I would like to keep going further to find all the real zeros of this function, I can actually go ahead and do that. And that's actually what's going to happen in this next problem. So I apologize here if I did not leave enough room, guys. All right, but hopefully you guys can squeeze this in there. But here, I want you actually, let's do one thing. I want you to look at the difference between both of these questions. The first one said, use synthetic division to find f of x divided by g of x. Assume that g of x is a factor of f of x. So all I was doing there is just dividing out those two functions, f of x divided by g of x. Now, that process that we use there is going to be helpful for the second part, but here is something I need to make sure is absolutely clear. For the second part, we need to use the given zero. So we were given something right there. We were given that zero, which is negative 1. And we want to find all the real zeros of the function. So actually, I already know one of the answers. All right. Remember, we're going to get 3 solutions here, guys. We're going to get 3 zeros. And actually, I'm going to start off with my set notation before I even start the problem. Okay? You don't have to do this, but this is just so I don't forget it. Remember, guys, we talked a little bit about how, because the highest degree here is 3, there's potential for 3 real zeros. They actually gave me one. It's right there. Remember, you were given a 0. Okay, and that first 0 is negative 1. So I'm actually going to write that one down already. Negative 1. Okay, I should get 2 more answers, and that's what we're going to have to work for. We're going to have to work for finding those 2 other answers. So let's go ahead and do this, guys. Now, here's one thing you got to remember. That is the 0. So actually, there's no setting it equal to 0 anymore because that is the 0 itself. That negative 1 is what goes here. That's my box number. Now, I just have to go ahead and drop all of my coefficients. 1, 7, negative 1, negative 7. And then we can start our synthetic division. So this is negative 1 times 1 is negative 1. Add 7 plus negative 1, we get 6. Negative 1 plus 6 is going to be, oh, sorry, my fault. Negative 1 times 6 is negative 6. Oh, forgot to box my last one. Negative 1 plus negative 6 is negative 7. And sure enough, one more time, negative 1 times negative 7 is going to give me a positive 7. So we actually did get a remainder of 0, which actually, guys, you're going to notice once we keep doing more and more of these, we better get a remainder of 0 because otherwise I'm not going to be able to factor that or do quadratic formula on it. So this gives me 1x squared plus 6x minus 7. Now, guys, that is a function. It's in ax squared plus bx plus c form. This is what I need for the quadratic formula. Remember, guys, we can set this equal to 0 and solve to find the remaining x's. So that's exactly what I'm going to do. That's what we did yesterday, kind of as an intro yesterday, but that is exactly what we did yesterday. So let's go ahead and do that. So we have all the information we need. I can go ahead and apply quadratic formula for anyone who still doesn't quite remember it. Here it is. Opposite of b plus or minus b squared minus 4 times a times c all over 2 times a, just like that. But I actually have numbers to substitute in there because they're all right here. Okay, all my coefficients are there, so let's do that. That's going to give me x equals opposite of b is negative 6 plus or minus the square root of b squared minus 4 times a times c. But I know what all those numbers are, guys. It's 6 is my b, 1 is my A, negative 7 is my C. And then finally, all of this is over 2A, so 2 times A or 2 times 1. Now, we got to go ahead and figure out what is under this radical. Remember, guys, that's your discriminant. We got to figure out what that discriminant is. So b squared minus 4ac, I'm going to actually go ahead and type that into my calculator here. Let me see if I can pull it up. And here we go. So we have 6 squared minus 4 times a times c, which was a negative 7. Let's see what we get there. We ended up getting a 64. So let me go right back to it. So we got 64. Okay. We got under the root, guys. We still haven't done anything with the root. Don't forget it. It's still there. And all of this is over 2. Well, actually, I can figure this out because the square root of 64 is actually just 8. So this is really negative 6 plus or minus 8 over 2. So now all I got to do is do my two cases. Either negative 6 plus 8 divided by 2 or negative 6 minus 8 divided by 2. So this is going to give me 2 over 2 or just 1. Here I get negative 14 over 2, which is negative 7. And hey, look at that. Those are the two solutions or the two zeros that I was missing here. Okay, I was given one at the very beginning. Right here, negative 1. But then I found two more. These are your solutions, guys. These are your zeros. So negative 1, 1, and negative 7 are your solutions. Those are your zeros. Now, if you want to put them in the right order because technically they should be from smallest to largest. It would look something like that. For now, I'm totally cool with this, guys. But just know that the formal way of writing it would be in that way. Okay. All right. Why don't we do one more? Let me see. What's a good one? Let me actually skip number 6 for a second, guys. Let's go ahead and do number 7. Okay, let's go ahead and do number 7. So number 7, again, guys, this is our solution already. That is our 0. Okay, so I'm going to actually go ahead and use that as my box number. I'm going to go ahead and place all of my coefficients here, 3, negative 1, negative 62, and negative 40. And this is going to be drop the first, box the last. Let's see what we get. Negative 4 times 3 is going to give me negative 12. Negative 1 plus negative 12 is going to give me negative 13. Now, negative 4 times negative 13 is going to give me 52. Negative 62 plus 52 is going to give me a negative 10. Finally, negative 4 times negative 10 is going to give me positive 40. And again, guys, we got lucky, and we should get lucky here. Otherwise, we will not be able to solve for this quadratic. So we get 3x squared minus 13x minus 10. This is the quadratic I have to solve. Okay, this is what I'm going to have to use my quadratic formula on. So let's do that. Here we go. Opposite of b, so 13 plus or minus b squared, so negative 13 squared, minus 4 times a, which is 3, times c, which is negative 10. If you're confused where I'm getting those numbers, guys, they're right here. A, b, and c. A, b, and c. Okay? And this is all going to be over 2a, so don't forget that part. People often forget that. So 2 times a, 2 times 3. Remember, your 3. Oh, sorry, your a is a 3. So let's go ahead and figure out what the heck this all is. It looks like a pretty big number, so let's go ahead and do that, guys. Let's go ahead and figure it out. So this is going to be, let's see here. It was negative 13 squared minus 4 times a, which was 3, times c, which was negative 10. Let's see what we get. We got 289, so let me get right back to it. This gives me x equals 13. Plus or minus, again, I have not done anything with the root, guys. It's still there. But underneath that root, I got a 289. And don't forget, this is all over 2 times 3, or 6. So I'm getting closer to it. But now, I can actually figure out what is the square root of 289. Okay, that is going to be 13 plus or minus the square root of 289. Let's type that into the calculator. If I type that into your calculator, if I can find it, here we go. We're going to get the square root of 289. 17. So, nice round number. That's helpful because when I separate this into two cases, I can find my two solutions. So either I'm going to get 13 plus 17 divided by 6, or 13 minus 17 divided by 6. This is going to be 30 over 6, which actually gives me an answer of 5. Here's one of the zeros. This is going to give me negative 4 over 6, which is negative 2 over 3 after I simplify it. And now I have all three of my answers. Ready? Here you go. They are negative 4, positive 5, negative 2/3. Final answer one more time. Negative 4, negative 2/3, and 5. These are my three real zeros for that particular function. Okay? I'm going to actually pause the video, or sorry, I want you guys to pause the video at this time because I want you guys to try number 8 completely on your own. I'm going to let you guys try it out, and then I want to show you at least 2 more examples of some older stuff that we've done in chapter 5. So go ahead and take a moment to pause the video, come back so you can double check your answer. Okay, guys, so check it out. Here is my final answer for problem number 8. Let me just walk you guys through it real quick, show you guys what I did. So what I did here was, once again, this is my first zero that was given, and that zero, I'm going to use it as my box number here. So I'm going to go ahead and set up my coefficients, 2, 3, negative 11, and negative 6. They're all lined up right here. Apply synthetic division, and after I do that, I end up with a brand new function. But that function is a quadratic. We literally have a formula named after that quadratic. All right, it's a quadratic formula, guys. So I applied that. I found what's underneath the radical, our discriminant. That gave me a 25, but remember, guys, the square root of 25 is just going to give you a 5. So now that I did that, I can separate my two cases for two final answers of negative 1/2 and negative 3, negative 1/2, negative 3. But do not forget, guys, you had one right there. All right, you were given an answer right from the very beginning, which was 2. Okay, that is how we find the zeros of any polynomial function, or at least for now, those of degree 3. All right, these should be pretty much reviewed, guys, even from way back in chapter 5. But let's go ahead and do at least one of each, guys, just to make sure that you guys still know how to do these, and then we will finish the video for today. So on this first one, guys, you are being asked to factor the following by grouping. So let's go ahead and try that. So that is gonna, let's see, we're gonna go ahead and group the first two, and then group the second two terms here. So I'm going to get 3x squared in common here, looks like. I factored out a 3x squared, and I'm left with 2x minus 7. Over here, let's see, looks like I have an 8 in common. So I'm going to pull out an 8. So I get 2x minus 7, as I should. Okay, especially if this is going to work out nicely. So I'm going to get 2x minus 7, which is one factor, and 3x squared plus 8. Remember, whatever was left on the outside, that is the second factor. And actually, that is it. That's all they asked me for, guys. They just told me to factor. These are the factors. Can't go any further than this. We are done. If we were being asked to solve, like problem number 11, I have to go a little further. So let me show you guys number 11. Same thing. Well, let's go ahead and do the same thing. Group the first two, group the second two, guys. And by the way, just FYI, the reason I know to do that is you see those 4 terms there, guys. Those 4 terms usually are an indication that you have factor by grouping. So I'm gonna go ahead and check the first two, see what they have in common, and it looks like they have an x squared in common, and I'm left with 7x minus 6. On the second set of terms here, I got 9 in common, but be specific here, a negative 9 because of that negative leading coefficient. So I'm going to go ahead and take out a negative 9, and I'm left with, let's see, I'm going to be left with 7x minus 6. All right. Now, don't forget that this is all set equal to 0. Do not forget this, guys. You need to keep track of that because you're going to need to do that towards the end. So I did match in my binomials here inside the parentheses, so that's going to be one factor right there, so 7x minus 6. What was left on the outside here is your x squared minus 9, and that is all going to equal 0. Again, do not forget this because had the directions said factor, I would actually be done right here at this point, but I'm not because the directions don't say factor. The directions say to solve. So I need to set each of these equal to 0 to find my solution. So I'm going to go ahead and do 7x minus 6 equals 0 and x squared minus 9 equals 0. Okay. Hopefully not too crazy here, but I'm going to get 7x equals 6 divided by 7. I get an answer of 6 over 7. That's my first answer. However, over here, I'm going to have to get this x squared by itself, guys. So get rid of that 9, the negative 9. So I'm going to do x squared equals 9. Now, to get rid of a squared, we have an inverse property for that, and that's the square root. Okay? So we need to square root both sides to get x equals, and this is what you need to be careful with, guys, plus or minus. Do not forget your plus or minus. And finally, the last thing, guys, is you will try to do some work off to the side here to try to simplify the square root of 9. Okay? But actually, we don't even need to do any of that because the square root of 9 is a perfect square already. That's just 3. So I have my 3 answers already. -3, +6 over 7, and +3. Or if you don't like this format, guys, you can always write it as plus or minus 3 and 6 root 7. Either way is fine with me. Both of those are correct answers. Okay? All right, guys. I actually think I'm going to cut off the video at this point now. I want you guys to go ahead and keep attempting 10 and 12 to double check that you guys did them correctly. Remember, the answer key to this is ready and available, so you guys can go ahead and take a look at that whenever you guys finish those two up. So other than that, guys, make sure you try the practices. Remember, you are trying day 2 of 5.4. Make sure you try that practice, and I will see you guys in the next one. Have a good one.